Okay, Michael, Matt, does that series converge? Grant says it depends on what x is. What kind of series is this? Okay, it's geometric. Now remember, what's a series? Sum of a bunch of terms. Okay? A sequence is a list of the terms. A series is a sum. Not only that, if I list out these terms, what's the first term? It's 1 plus, then what's the next one? X. This is one we have to know, by the way. Okay, Matt? Don't do that, please. X squared plus x cubed. This is the nth term. They're going to ask you for the nth term on the exam. That still goes forever. Now, guys, if you don't pay attention, this is the important part right here. This is the free response question. This is called a power series. Oh, yes, the free response will be like this. It's a power series because it's a series and these are all powers. It is geometric. It's also a power series. Now, Grant says this will converge depending on x. What has to be true about x? X is less than 1. Does that work? So if I put in -2, that's going to work? Okay. Or the absolute value of x is less than 1. Okay. So if this is true, okay, guys, if x is between 1 and -1, what does this add up to? We can find the sum of the series. This is one you have to memorize. It's geometric, so it's a over 1 minus r. What's a? Sorry. A is 1. I like to write that out. I mean, that's just for me. What's r equal to? X. So s is equal to 1 over 1 minus x. So what they're saying here, hey guys, they're saying that if you add this up, this series of powers, guys, please don't talk. You can talk to them later. That's equal to this rational function. Oops, that's 1 minus x. So what I've done is taken a rational function and written it so that it equals that polynomial. Well, that's what we're doing in section 8.5. We're not quite creating power series yet, but that's what a power series is. And we can graph this. And I don't know if you remember, but we did graph it. And I'm just going to slide this over. And if you don't have the new operating system, that's fine. You can just type in 1 plus x squared plus x cubed. How many terms do you want? That's only 4. How about 2 more? X to the 4th. Oh, worse than that. So I'm going to do an insert. I forget about that with the new operating system. It's good and bad. Yeah. There you go. Insert plus. Okay. Doesn't really mess it up. Plus x to the 5th. And then down here, I'm going to put in the graph 1 divided by, I mean, this should be amazing to you, 1 minus x. That's a rational function. That does not behave nicely. Its derivatives are not nice. Do you want to do an integral of that? It's a log. We will. It's much easier to integrate the power series. And we will zoom it 4. power series, there's the function. So if I change the graph, because you just told me it only converges between 1 and -1, but not at the endpoints. Okay, now we're going to see the rational function coming here. It's pretty darn close. I think that's really cool. And that's where the application comes in. Because when you're in biomedical engineering, you don't deal with functions that look like this. You deal with the power series associated with it. Because they only need a few terms to get a really good approximation, especially if it's alternating, because it converges very quickly. Okay. Now, do you see what a power series is? Now we'll get into the ugly stuff. Okay, now it's going to take a little jump to be something more difficult looking. These C's are just the coefficients. There's some number, but this is a power series because it's a series made up of powers. I think I skipped x squared, but you know what? It doesn't really matter. Although I should have had, this should have been x squared. And then the next one would be C3x cubed, etc. There. I have a couple typos there. Okay, Grant? The C's, you know what coefficients are? I'm going to use the word. Coefficient, those are the numbers in front of the x's. Okay, well, comes from the Latin coefficio, which means to begin. Okay. It's a series of constants, and we can test for convergence or divergence. It may converge for some values of x and not others. And that looks like a polynomial. Remember what polynomials look like? Polynomials are nice because they're smooth. There's no problems with them. They're continuous. They behave very nicely. Okay. And we already did this one. What kind of series was this? X to the n. This was geometric. And we will be looking at all of the cousins and the relatives of this series. That'll be an 8-6. And it's so critical you do that section because it's always on the exam. It's always in the multiple choice. Always. And I don't like to use always unless I really know for sure. But you will see on your test many of them. And this series converges to 1 over 1 minus x when the absolute value of x is less than 1. It's a power series. Let's do that. So when we do Taylor series, Taylor series are also power series. But they're named after the guy named Taylor. And then there's another one named Maclaurin. And honestly, these guys get credit for things they didn't do. I don't think Taylor was the one who actually invented the Taylor series. But that seems to happen a lot in math. Now, you guys, we could translate this function over. Grant, you're not going to understand how to do this. Tori, you can't miss any more class. So don't do that. Yes, I saw you. I watched you do that. Okay. Okay. We can translate everything over A units. So this is called centered at A. It would be like writing the equation of a tangent line, not at the origin, but someplace else on the curve. Okay, Sam? So here's my curve. Here's my origin. I could center my tangent line here. Okay, Elizabeth? You're not going to get this part about being centered. I could write my tangent line at the origin if I wanted to write that one, or I can do it over here. But we're not going to be doing just lines. We're going to have more terms than that. So if I put in x equal to a, what happens here? If x is equal to a, what does this all add up to? Except for this term. It converges. And this is x minus a to the 0, and we know that that is equal to 1, even when x is equal to a. Okay? We're going to use the ratio test. I want to find out when these converge. They're not geometric if they have factorials in them. And so when I look at example 1, there's a factorial. Are there any values of x, Grant, where that will converge? I can't look at that and say, well, it'll converge when x is less than 1 and greater than negative 1. I don't know. So we're going to use the ratio test to find out when this converges. Here's where we use all those little divergence and convergence tests. So here's the sum. It's n factorial, x to the n. N is equal to 0 to infinity. So let's do the ratio test. Do you remember that? There wasn't, I don't think there was any of it on the test. Because the ratio test is right here. The If a function converges absolutely, then the original function does. This is always positive terms anyway. This is the ratio test. If this is less than 1, this series converges. If this is equal to 1, we know nothing. And if it's greater than 1, it diverges. So we're going to do the ratio test on this function. So if I just slide this again. And so it's the limit. You should do it with me. As n goes to infinity. And do I need the absolute value? These are all positive. Do I need absolute value? No. So we're going to put in n plus 1. I don't know if you practiced and did section 8.4 on the ratio test. X to the n plus 1. And then what are we going to do? We're going to divide by what? N factorial and x to the n. And oh, I do need the absolute value. So I forgot about x. X could be negative. Whoops. And that's less than 1. I want it to converge. I'm going to get an inequality with absolute value. Can I find x's so that converges? I might not. I might not. Will it converge if x is 0, by the way? If you put in 0 here, what's 0 times n factorial? 0. Yes, it does. 0 factorial is 1. But x to the n is going to be 0. Okay, so let's do this. It's the limit. Now, does the limit affect the x's? No. What's n plus 1 factorial? It's n plus 1 times what, Ori? N factorial. That's why you need to pay attention. Now, are we okay with n plus 1 factorial? It's n plus 1 times n factorial. Okay, we've done that. Then x to the n plus 1 is x to the n times x. Grant, is that okay? No, if it's not okay, you have to tell me. We did this before. N plus 1 factorial is n plus 1 times n factorial over x to the n. You guys, is that okay? I just rewrote it. Now, can things cancel? Eric, what cancels? Those cancel? What else cancels? N factorial cancels. Factorial cancels. And I'm left with the limit as n goes to infinity of the absolute value of n plus 1 times x. When's the only time that's going to be less than 1? There's only one value. What's going to happen to this? It's really the limit of this. As n goes to infinity of the absolute value of n plus 1 times the limit as n goes to infinity of the absolute value of x is less than 1. What is this limit? No, that's infinity. The only time it's ever going to converge is when x equals 0. So a power series may converge only for 1 point. That's the situation. It might converge for an interval, or it might converge for everything. Ready? Because this is 0. If I put 0 in there, it's 0. Would you put that away, please? Whose phone is it? We'll give it back to Libby. Here, I'll take it. Yeah, I don't want to see them out. Let's do another problem. Let's find this one. You need to do it with me. We're going to do the ratio test. Now, this is centered at 3. What if I put x equal to 3 in? Will that converge? Yeah. Are there other values where that will converge? I don't know. So a series will always converge at a single point, or over an interval, or everywhere. I don't know. I've got to do it. The limit as n goes to infinity, and now it's the absolute value of x minus 3 to the n plus 1. Okay, you should be doing it with me. Over n plus 1. And then I'm going to divide by x minus 3 to the n over n. But I don't want to do that. I'm going to multiply by the reciprocal because then I can do it all in one term here. Perfectly acceptable, by the way, to do that. That's when it's going to converge. So first we're going to take the limit, and we're going to simplify that. We always want to simplify things. Because it's the limit as x minus 3 to the n. Sorry, copied it wrong. Okay, it's a sub n plus 1 over a sub n. This converges if that's less than 1. Because that's the nth term. Because I really have this x minus 3 to the n plus 1 over n plus 1, and all of that is divided by n over x minus 3 to the n. Well, I don't want to do that division. I'd rather multiply by the reciprocal. And that's perfectly acceptable. Oh, I copied this one. Well, I have to have it right because it's wrong if it's wrong. X minus 3 to the n, yeah, over n. And then I multiply by the reciprocal. Oh, mess me up. Okay. Okay, what's this going to give you? X minus 3 to the n times x minus 3. Is that okay? The algebra. And this is, now let's switch these factors. Then that's x minus 3 to the n. I don't have to do it. It's just easier to see. Then this is n over n plus 1. All I did was switch the factors. I took these two factors and switched them. I put the x minus 3 on the left side and n plus 1 on the right side. Because if this is an exponent of 1, this is when you truly learn your exponents. Okay. Marshall, Bjorn, you have that down now? What cancels? And does the limit affect the x minus 3, or is it really just affect the n over n plus 1? The limit doesn't affect the x's. It only affects n's. So let me slide this so it's not so low on the board. Okay, and what is this limit? It's 1. So I get this inequality. X minus 3 is less than 1. This is centered at 3. Now I'm going to do this two ways. I'm going to do this the geometric way and then the algebraic way. Okay, I want an interval. This says I'm going to start at 3, and I want the distance between any value on this number line and 3 to be smaller than 1. So where would this be? Where would it be? Be at 4, wouldn't it? And then this other side, Grant, would be where? I want the distance between any line and 3 to be less than 1. So this is 2. Okay, this is called the radius of convergence. You could make a circle. That's right. If you were to go into 2 dimensions, it would look like that, more or less. Radius of convergence. It's also r equal to 1 if they're in polars, which we'll get to. This is centered at 3. Okay. Now, to do it algebraically, you would put x minus 3 be less than 1 and greater than negative 1. and then you would add 3 to all sides. Now, that's the interval of convergence, except I must check the endpoints. Because when I put the endpoints, when I put 4 or 2 into my ratio test, I get 1. And we know nothing about 1. I don't know. I got to do some work. If I put this into my convergence test, if I put in 4 right here, what is this limit equal to then? Corey? Eric? What does that interval equal? What's that equal to? That limit equals 1. I don't know anything at 1, do I? What if I put in 2 here? It's still 1. I still don't know anything. But if I put a number, Eric, put that down. Okay? If I put any number between 2 and 4 in there, it will converge. So what am I going to do with 4 and 2? Now, this is worth 6 points for you guys on the exam. Easiest points you can get. That was last year's. Now you can do it. Tomorrow we'll start the class with last year's problem. You have to actually put in 4 into my original series. So I'm going to copy it over here. And this is when we use all those little tests. Guys, don't do that. I know. I don't know why you're so close. No. Okay, so we're going to put n equal to 4 in here. Then this series becomes 4 minus 3 to the n over n. And n is 0 to infinity. I'm sorry, x. Then what is that? Yeah, that's 1 over n. Guess what? Does it converge or diverge? Okay, so it will not converge for 4. Do not assume that both endpoints do the same thing. I don't know. So this harmonic diverges. Now, what's the other endpoint? X equals 2. Okay. X equal to 2 is going to be 2 minus 3 to the n. Eric, over n. What is this going to give me? I should have started with 1. Why is this convergent? Because this is the alternating harmonic series. Alternating harmonic. You should go to the nurse. Okay, I didn't answer the question. When does this converge? Between 2 and 4, but including 2. This is the interval of convergence. Eric, I think I might have to put you over there because it's not working with you right here. Yes, I know what he's doing. Okay, this summarizes the whole thing. The series converges. It might only converge for x equal to a. Because if x is a, what is going to happen to this? It's all going to disappear. It's 0. It might converge for every value. We haven't done one like that yet. Or it might converge such that it's only convergent on an interval. Notice it's 1x minus a. You can't have 2x minus a. You'll have to factor out the 2. We'll do something like that. That's why you need to practice with this. It diverges if x minus a is greater than 0. This number over here, once you get 1x minus a, that's the radius of convergence. So in this case, the radius of convergence here is 0. It only converges at 1 point. In this case, if it converges for all x, the radius of convergence is infinity. And in this case, I think my radius of convergence has to do with this situation right there. I don't want to write it again. So all we're going to do is do the ratio test. So if you haven't practiced, you get to practice now. And you have to check the endpoints. Do I have that written here? We must check the endpoints. And if you don't do that, it's sort of like those, do you remember solving differential equations? And how you get 6 points for that, and if you don't put in the C, you're done right before you even start. It's the same kind of thing. You got to check the endpoints. You get a point for checking the endpoints, even if you do it wrong, which is really nice. Okay, so let's try another one. The ratio test always fails when x is the endpoint. Why? Because you get the ratio test is equal to 1. That's the problem. So let's try that. We're going to find the radius of convergence and interval of convergence. So you should turn to this page, and we're going to do this problem. I think I have 2 problems left to try. That one and the one on the next one. Somebody want to come up and try it? Anybody brave? Oh, that's not what I want to do. Okay, so I should see everybody trying this problem. Except for David, who's sleeping. Here's your ratio test. By the way, you get a point for realizing it's the ratio test. If they ask for an interval of convergence or radius convergence, that's what they're asking for. So we're going to put this in. Do the best you can. Otherwise, you can go in the middle. So it's negative 3 to the n plus 1, x to the n plus 1, and what happens down here? N plus 1 plus 1. Hey, Grant, you should be doing this, not watching me. Watching's not going to do any good. Okay, times, no, you should be doing, and then what am I going to put here? Square root of n plus 1 over negative 3 to the n, x to the n. Usually this is everybody's favorite thing because they like doing the algebra, especially when it gets to canceling things out. I cannot look at these. If I can recognize it as geometric, then it's good. You can do that. But if I can't, do you have to check the endpoints on a geometric series? No, because you know it never converges on for a geometric series. But those you need to know those. Not in that situation, but a normal one, yes. So what is this? This is negative 3 to the n times what? Negative 3. This is x to the n times x. And then I have the square root of n plus 1. So I just left my numerator right where it was. It's all multiplied together. And then let's reorder the denominator. Question. Do you agree that this is negative 3 to the n plus 1? Okay, Matt, put your phone away, please. Then this is the square root of n plus 2. I'm going to put it over here because it looks like that. Negative 3 to the n, I'm going to put it under negative 3 to the n. And x to the n, I'm going to put here. Now, I don't have to do that. I just think it's easier to see, especially when you do the limit. And everything, a lot of things are going to cancel. What's going to cancel? After we're done with this problem. What's going to cancel here? They're going to go. What else is going to cancel? Okay, that's it, right? So I have the limit as n goes to infinity. That's the absolute value of x times, and I'm going to write this under the radical like this. Can I do that? Are you guys okay with that? Oh, and I lost my negative 3. I was just going to check. Because that is good. Square root of a over the square root of b can be written as the square root of a over b. Because now when I take the limit, maybe it was okay before. What's this limit going to be? 1. Be careful that you recognize when it's e. Because sometimes it's going to be e. If not today, it's just going to be 1. It's e is the limit as n goes to infinity of 1 plus 1 over n to the n. That's e. Yeah. Pardon? Yes, it does happen. Okay, but we know that this is 1, right? So I'm going to be left with this. Now this is my radius of convergence 1? No. no. Oh, I lost my negative. Thank you. But I'm going to absolute value it. Because remember, the absolute value is going to get rid of that negative, so it's this. But you have to divide by the 3. So it's the absolute value of x is less than 1/3. Because I can write this way. This is the absolute value of negative 1 times the absolute value of 3x. Do you know that property of absolute values? Property of A times B can be written this way. Absolute value of A times the absolute value of B. Can I do that with a sum? Can I write that as the absolute value of A plus the absolute value of B? Yeah. What if A is negative 5 and B is 2? No. But I can with multiplication. And break that up. So the negative 1 isn't going to matter. Okay? And now, what's the radius of convergence? Because they may ask you that. What's the radius of convergence? It's not 1. It's 1/3. Remember? This coefficient has to be a 1 in front of the x. Now, where am I centered? It's really this. Where am I centered? I'm centered at the origin. So what does my interval look like? I think it's just as easy to do this, to say we're going to start at 0 and be 1/3 to the right and 1/3 to the left. Now the question is, do we get to include the endpoints? Sorry, lost my negative sign. Question? Because it has to be x minus a is less than r. The coefficient of x must be a 1. This is not. I have to divide by 3. So my interval of convergence is really small. You can't have that 3 there. You have to divide by it. I do. This is the... No, it's 1/3. I divided by 3. I divide this by 3 and this by 3. Lizzie. Mm-hmm. It doesn't matter because it's an absolute value. So, yes, this is going to be this. This limit is 1. And it doesn't, n going to infinity has nothing to do with negative 3 or x.
I know what you're saying.
Okay.
So, does that negative 3 get multiplied all across?
It's not distributed property. So it's 3 times the limit as n goes to infinity of this. This limit is 1. I have it. It's right there. It hasn't gone. It hasn't gone. No, I then made it positive because it doesn't matter. Hey, Eric and Ori, what do we have to do now? Check the endpoints. It's not distributed because it's not a sum. I think that's what she's thinking. If that were plus here, then you would distribute the 3, negative 3, but it's not plus. Okay. Now I got to write the series down again because I'm going to forget what it is. Negative 3 to the n. And this is why we did all those convergence tests. It's negative 3 to the n. Is it over n plus 1? And it's at x to the n? Okay. Oh. Well, I can make it a difference. Okay. Now we're going to try x equal to positive 1/3. Then this is going to be negative 3 to the n times, 1/3 to the n all over the square root of n plus 1. Is that okay? Now you tell what to do with this. This is the same as this. This is negative 1 to the n times 3 to the n. That's that negative 3 to the n. That's the same as this. and it's times 1 over 3 to the n, and that's all over the square root of n plus 1. What happens to the 3 to the n's? They cancel. And what am I left with? Summation of negative 1 to the n over the square root of n plus 1. Alternating series. So does it converge or does it not converge? It converges. So I said the convergence tests, except for the plain multiple choice problems, are when we do the series, is usually easy stuff like this. Now let's do x equal to negative 1/3. It's the algebra that's going to probably get us into more trouble, but we'll see. It's the summation of negative 3 to the n. And what am I going to put in here, Eric? Negative 1/3 to the n, all over the square root of n plus 1. I put in x equal to negative 1/3. What's going to happen to the negatives? I can write it out if you want me to. They're going to cancel out, aren't they? Because this is really negative. Now, you don't have to write this step. And this is really a negative 1 to the n times 1/3 to the n, all over the square root of n plus 1. So the 3 to the n's go, and a negative 1 to the n times negative 1 to the n will end up being a positive 1 always. So it's this summation. These take a lot of space. Did I converge or diverge? It diverges by what reason? By the p-series. Do you have to use the comparison test? I don't think so. I've only graded one of these. That was last year. Wish I'd graded more. Then I have more information. But okay, have to answer the question. Let's see, negative 1/3 did not work, and positive 1/3 did work. So the answer is from negative 1/3 to positive 1/3, including positive 1/3. That is the interval of convergence. Should we do the AP problem, or should we wait and do that tomorrow? Oh, okay, we'll do one more of these then. Oh, we're not done. I have still one more problem. I'm going to let you guys try it, though. Whoa. There you go. Do you want me to help you set it up? It's the limit as n goes to infinity, a sum n plus 1 over a sum n is less than 1. We're just trying to find the x values. What if x is negative 2? That's 0. Okay, Eric? Eric, you're going to come up and do this? Probably not. Oh, yes, you can do it. Usually this is everybody's favorite part of the unit. All over. It's 3 to the n plus 1 plus 1, so it's n plus 2. Times. Is it easy to miscopy this? Probably. Okay, I'm going to give you a chance to try it. Okay, Eric, try it. On your own paper, try it. Come on. You guys aren't going to know how to do this unless you try it. You should find these kind of fun, really. Oh. You get the absolute value of x plus 2 is less than 3. What's the radius of convergence? It has to be 1x. It has to be. Okay, John, what's the radius of convergence? radius is 3. Now, where is this here's the easy way. Don't even think about absolute values. Think about what it means. It's centered at negative 2. At least I think this is the easy way. And I want to go 3 units to the right. Where am I going to be? 1. We're going to be 3 units to the left. Negative 5. Now, does it converge at 1? I don't know. At 1, it's going to be n, and it's going to be 3 to the n over 3 to the n plus 1. Is the limit of this sequence, is that equal to 0? No, because this is really this. It's n over 3. The limit as n goes to infinity of n over 3 is what? Infinity. What if I make it the negative 5? Then it's going to alternate, that's true, but it's going to be this. Is the limit of that sequence 0? No, so it doesn't converge for either one. But that's just a 3. If I had the n in the denominator, life would be much better, but it's not. So that's the answer. Negative 5 to 1. I will let you look at that. Where's my little clock? If you want me to evaluate it, I will. You can't control yourself?
No, I can't control the urge to ask for food.
Well, bring some food.